Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Dr. Madelon Hulsebos, one of the world's leading scientists on table representation learning and understanding structure and AI. I think this is just one of the most exciting topics. I'm so excited to talk to Madelon. Thank you so much for joining the podcast.
Wow, fantastic, Connor. Thank you so much for the invitation and great to be here. Just one correction. I'm not a doctor yet,
Oh, sorry,
but
let
I'm
me...
no. I'm about to actually hand in my thesis today. So
Oh.
no, it's almost accurate. Almost.
That's awesome. Yeah, I actually had the same thing where I submitted my dissertation and then did a podcast with Bob like right after. So awesome. Glad to be a part of that. But so
It's successful timing, I guess, right? Yeah.
yeah. So this topic of table representation learning, I think this is just so exciting. I've been trying to understand the role of structure in vector search for so long, and I think kind of the question I'd want to kind of set the stage with is to understand, tabular data. It's always has this narrative of, most of the world's data is in tables, and people have this mix of like numeric, categorical features that they organize, and to just kind of understand like the intersection of that and embeddings and how you kind of see that.
Um. Well, I think in terms of the intersection of tables and embeddings, I think it's always been very confusing to people. As people, well, I think now most of the research has been focused on, language embeddings and just, very raw text embeddings, and then everyone is, of course, very keen to adopt such techniques and models and embeddings directly for tabular data. But I think what has been often misunderstood is that tabular data isn't as simple as just text.
Hmm.
So there are many intersections, though, between the two, and of course, many tables also contain text. But as you said, there's just a lot of structure in tables. Columns all relate to each other, rows relate to each other, but they have also very specific properties that I'm sure, we'll get to in a later stage. Um, but yeah, I think it's a hard challenge and interesting challenge to also see how we can tailor all these, representation learning techniques towards embedding, for example, numeric data as well,
Hmm.
and see how they can perhaps complement each other.
Yeah, well, I think I didn't mean to limit it just to embeddings. I mean, kind of this whole idea of machine learning on tables, and I know things like table to SQL is one of these topics that we'll cover in the podcast, and so I guess that kind of idea I want to explore more, like so embeddings of numeric properties. So maybe like you have a patient electronic health record, and you'd have like an embedding for the age attribute. So is this kind of the thinking, like you take like a table row that would describe electronic health record, maybe just to stay in that one, and instead of maybe translating it to text and sort of putting the text translation of the tabular row into like OpenAI embeddings, you instead have some way of learning representations for tabular patients.
Yeah. So I think there are quite some flavors to this task. One of them is indeed for tabular machine learning, where indeed you have row-wise embeddings and want to perform some kind of classification task on top of that.
Hmm.
So that's one big field that is now actually coming up with pre-trained models such as TabPFN. Very interesting to check that out. It was coming out last year. And you can just use such embedding models on top of, indeed, for example, healthcare data to classify, for example, diseases, perhaps, although it's, of course, relevant to first evaluate that on specific use cases and domains. But then there's also another field that has been training these models across like millions of tables to, for example, retrieve embeddings to service the semantics of columns. For example, to generate metadata. So, if you want to build a data model and perform, for example, data validation on all such columns that contain ages, for example, of patients, it's very relevant to understand how different kind of tables relate to each other. So
Hmm.
what actually I've seen a lot is that different healthcare providers, they want to integrate different sources of tables of their data, and then they want to integrate this data together. But because everyone has different concepts to refer to ages, for example, and
Hmm.
different ways to specify such attributes, it's very hard to map a column of ages in one table to another. So this is a very interesting use cases that can be performed if you have accurate semantic embeddings of table columns, for example.
Yeah, I think as I was studying your work and learning about this kind of semantic type detection for columns, that was quite new for me to have this idea of you're looking through a table and you're like, what is this column talking about, right? Is it? I'm almost like I'm very like kind of at the crossroads of where to go next in our conversation, because we could talk more about this kind of column type detection, or that idea of like table embeddings, like not just individual patient level, but searching through the whole table. I find that to be so fascinating. So yeah, maybe if we could stay on the type detection, we'll come back to the whole table embedding level. But this semantic type detection, can you just kind of like the beginning, because I imagine this is kind of new for a lot of people.
Yeah, so I think one of the key tasks in many data management and many data analysis applications is driven by the semantics of columns. So indeed, what do columns really represent? What's in that column in like real world concepts? So for example, with the example of ages, you want to label that with like standardized semantic types:
Hmm.
age, address, and there are like millions of different types that you can think of, but then all in a standardized way. And this is actually a key task for table comprehension. So basically, table understanding, as you might also see, for example, analogous to, for example, images where you have object detection. You want to understand, if there is a cat in an image or something like that. You want to have something similar for tables to understand what these tables actually contain.
Hmm.
But this can also be used for example, data discovery. If you have accurate embeddings or representations of columns. Um, and you can generate metadata such as semantic column types from that. Then you can use that also for data discovery, for example, or recommending data visualizations for specific tables, given that the
Hmm.
tables contain certain semantic types.
Yeah, I think the timing on that is amazing with Snowflake acquiring Ponder, and I listened to Doris Lee, things like the Stanford seminar, this like kind of data discovery, like kind of recommendations on analyses and visualizations of your data. And I guess I'm so curious. Like I've seen your work on Git tables, where you've extracted millions of CSVs from GitHub. Very cool. I love the data collection; is always awesome. But so you have all these tables, and now you're trying to say, I know like maybe two, three out of the five columns. Let me try to use that and the values to infer the type of the fourth one. Maybe help me further understand just kind of like the application of the type detection of the column and sort of the context it sits in.
Um, so ideally, we want to train machine learning models over all these tables to perform, for example, semantic type detection, labeling table columns with semantic types. And we want to do that also for new and unseen tables.
Hmm.
So that's basically the idea. And we can do that in, of course, very different ways. You can even just look at the header. So, for example, the column name.
Hmm.
Um, but the values in these columns are very, they provide very important signal to what these columns are about, of course. So typically we try to embed full columns to predict the semantic type of it.
Hmm. Yeah, so maybe looking at the distribution of the values, and so yeah, with that kind of thinking, I'm very curious, like how language models and sort of chaining. Maybe you have like how you can call the pandas functions, like df.describe is kind of like a common function that like gives you all these views of your data in pandas. How have kind of the language models help with that, interpreting what a column is in the characteristics of a column?
Well, I think that's a very interesting one, and basically where I myself started off with was with word embedding. So
Hmm.
assuming that many tables actually contain textual data, and this is a severe limitation actually of this approach. What we did back then is just trying to map every cell value in a column to, I think back then we had like glove embeddings. So we basically tried to aggregate all kinds of word vectors extracted from column values.
Hmm.
Now, I think there is, with representation learning, and this has been extended to tables as well with table representation learning, we see that typically what is most common to do is serialize entire columns, like cell by
Hmm.
cell, into a sequence and then provide it to language models basically. And there are kinds of like adaptations of the attention mechanism to also learn, for example, relations across different rows, across different columns. So there are many like tailored approaches to adapt such language models to tables as well. And this is super cool. This has enabled actually very interesting applications for, beyond table comprehension. So beyond semantic type detection, this has enabled, for example, question answering, fact verification over tables. And it's really, really super cool to see that. But of course, there are also limitations to such approaches.
Yeah, I think it would be a really nice transition to asking more about your work on that kind of table-based question answering. I think we've seen a lot of kind of like in the retrieval augmented generation tooling world, we've seen a lot of text to SQL kind of things. And yeah, if you could just continue on how you see that table-based question answering application.
Yeah, I think it's so one of the driving forces of Git tables was actually that most of these models, for example, pre-trained table models for question answering, they had been trained on tables from the web, and assuming certain structures of tables that were slightly short-sighted. So there's so many specifics to tables that you cannot just assume these models to work with out of the box. But for question answering, what I've seen is that uh, when you try to serialize these columns and rows, one thing that is typically missed is that there is, for example, properties such as row order insignificance and
Hmm.
column order insignificance about in databases, so in relational tables. And what is interesting about these current pre-trained table models for question answering is that they can be very sensitive to such characteristics. So one
Hmm.
of the driving forces of, for example, Git tables, but also more analysis work that we've been doing with, for example, Observatory, is to try to figure out how well these table embedding models generalize to different applications and different databases. And I think one of the shortcomings now is that, well, we have many steps to make still when it comes to scalability. So these models have been trained on, well, relatively smaller scale data sets of tables. Now, very recently, a huge table collection has been
Hmm.
introduced as well by Approximate Labs. Very cool to see where that is going.
Hmm.
This data set is called TabLib. And then I hope that these models will also become more robust, for example, for example, small semantic perturbations in tables. So what we've seen with Observatory is that, which is an analysis tool for trying to understand what table embeddings, how robust they are, basically.
Hmm.
One of the things we found there is that if you make very small changes to, for example, the question you ask, or the table that you ask a question on, even though the semantics, so the meaning of the question remains the same, they don't really capture that well. And I assume that when we scale such models up, that, as with large language models, these models will also become more robust to such semantic variations, for example.
I think with me, I'm trying to understand like the language model kind of uses like pandas or SQL APIs to kind of answer symbolic questions. Like it could take in the schema of the table and then it can format like select from where like the clause. And so I'm trying to understand like how you would have like instead pass in the table directly to a machine learning model that would output some kind of answer.
You mean if that is what we should be doing?
Yeah, I guess sorry if this isn't super well formed, but I'm trying to understand that. I guess for me, it's like these tabular machine learning models. I guess they take as input a table, right, or maybe a row, and then produce the answer based on by processing the table with some kind of like maybe column wise attention and this kind of thing. And so I'm just really curious how that differs from say. Just interfacing my large language model with like a Pandas or SQL API, where it can if it's doing symbolic, I guess like if it's doing symbolic aggregation, like what's the average age of country music singers? I say that a lot now, I guess, but like then it just has to like select from the singers table where genre equals country music, right? So I guess that kind of
Yeah, indeed. So this problem of question answering specifically has been approached from two directions. Indeed, one mapping natural language questions to SQL and then executing that on a given table, where of course the table schema is integrated into that, because you need to understand or need to map the like SQL attributes to a given column. I think that's actually a very good approach to take, and it's, I think, a very logical one also given the sequence to sequence modeling approaches that we currently have. um, and I think we'll see what I think it's a very interesting approach to take, but it's of course also limited, I think, with what applications you can serve with that.
mm.
um, but I think the other approach of, I think they kind of relate to each other as well a lot. Um, but for example, for fact verification, where you want to give a fact or check a given fact against a certain table, then we might need different
Mm.
embedding and different approaches to this problem. But I think text to SQL, I think it works well for relatively simple basic cases at the moment, and I'm really keen on seeing how well it works if our queries, our questions become way more complex. And very recently there's a new benchmark introduced that actually tests text to SQL models for way more complicated schemas, but also more complicated questions, because so far we've been only working with very small questions on a single table. And I think as soon as you want to, ask more complicated questions on your data, then it will become much harder to generate relevant SQL.
Yeah, I think that's so interesting. I've studied a little bit of like the spider data set for text to SQL, and I have a bit of experience with this because I've been working on the text to GraphQL Gorilla with Weaviate's GraphQL API, and so yeah, this thinking of like these complex schemas, like with Weaviate, we kind of have like a collections like abstraction where you have like a like student, teacher, book. These are like separate classes, and so it's like you'd only retrieve kind of one schema at a time to format the query for one schema. Hopefully that makes sense. But like if you're like joining, I can imagine like complex joins is where this problem gets really difficult. And I actually think that would be a really nice transition into the embeddings of tables as a whole, because I imagine there's maybe something to the join. It kind of with what you were saying earlier with I have this electronic health record where I have patients and I have age as one of my column values. Maybe I want to try to join this to some other table, but I'm not sure what which table, right? So I need to kind of like search through tables to maybe do that kind of joins.
Yeah, I think especially for such cases, you really need to embed the underlying data as well. You just mapping column names to natural questions and like generate SQL queries from that, I think won't work. If you want to, for example, integrate data from very different sources. I think there's actually a newer benchmark called BIRD, and BIRD really provides more complicated queries that all these models really find challenging. So I think it's really interesting to see that such applications will empower us to ask natural language questions over our data. But there are definitely many challenges ahead. Also, when it comes to, for example, the input limit. If you want to embed tables, that's a severe limitation because of the amount of context that you can provide. If you would then need to scale up across different tables, this becomes already quite challenging.
Yeah, I think that there's so much that I want to keep. I guess I really like this kind of like when I thought back about like electronic health records and embedding patient rows, I really like that kind of RAG where you would retrieve similar patients and then maybe have that kind of that the supplement in the input that comes from that. Yeah, I guess yeah, I kind of want to stay more on these complex questions, this text to SQL thing, and I'm very curious about this kind of like query execution planning. Like I don't know too much about how SQL does this, but I know that there's like a lot of underlying mechanics to like how to optimally do a query. Do you think about this kind of thing as well, and how machine learning could help?
Yes, that's a great question. I have been thinking about this a lot, but I haven't been working on this. And to be honest, I think no one really has. But there are so many opportunities, I think, when it comes to query optimization as well. But this is just guesswork at the moment and needs more experimentation. But I think there are very interesting opportunities when it comes to, for example, caching or as you said, yeah, I think that's an interesting direction to explore further.
Super cool. So, kind of pivoting topics a little bit, I kind of want to talk about the kind of. I'm very curious, like what you think about graph neural networks, because I've heard you talk about like column-wise attention and these kind of particular architectures for tables and relations. And I think graph neural networks. It's like always trying to figure out what it's going to be, what that's going to become.
I have seen some interesting approaches that indeed use graph neural networks to try to model the relationships in tables, and I think they are very successful. They can be successful, but I must admit that I'm personally not a big fan of graph neural networks themselves. I don't know why. It's just something that I don't know. It hasn't really taken off so far, I think. Um, but definitely there are different ways to also perceive tables, and you can also see them as they can be well represented by graphs as well. So I think there's definitely value in that, but I haven't looked into this myself.
Yeah, I guess it almost is like I guess with the graph neural network, you need to have like the whole graph as input, and I always thought that was kind of like it makes the inference kind of challenging. And so I guess kind of another thing I'm curious about is your current sentiment on like XGBoost and like especially in kind of like search and recommendation that like having symbolic features about your customers to then like re-rank your search results with an XGBoost model is quite a popular thing. And so yeah, generally I'd love to just get your take on XGBoost.
I think it was super interesting. Last year, we organized this workshop, Table Representation Learning, for the first time at NeurIPS. And by then, I've been mostly focusing on data management applications where we were more interested in the semantics of data, in generating metadata with, for example, semantic column types. Then, when we organized this workshop, people really related this to XGBoost directly. Anything on tables, people think like, no, but XGBoost, outperforms anything. And I was like, oh, but this is a different task. That's
Mm,
row-wise inference and
mm,
not necessarily, um, you know, across, generating general metadata from different tables.
mm,
And I think now we see that these fields actually approach each other. Whereas, for example, XGBoost is typically trained on one given table. But now, as we see also more representation learning being effective for learning relationships across different tables
mm,
for tabular, like row-wise inference, like XGBoost. And I think we see now more and more approaches that try to embed rows and see if that works for such cases as well. And I think they have been shown really competitive for against XGBoost and other tree-based
mm,
classifiers. So that is super interesting to see and come together, because before all these like more representation learning approaches, they also learned representations from one table, and now they start to explore trying to learn representations and like transfer semantics from other tables to do this kind of inference as well. And I think that's a super interesting area to see being explored.
Yeah, I think. Well, I guess it's like this idea of merging tables, and I guess generally like this generalization of symbolic. That would kind of be my why I don't actually prescribe people to train an XGBoost to re-rank their search results, is because the generalization probably won't be as good as if you translate it to text and use like a cross encoder that has a text. Is kind of my perspective, is that because when you have the symbolic things, you're like really like the machine learning model is like really fitting to these like high frequency patterns, I think, compared to kind of text translations where you have these like rich embeddings that I think generalize better. uh, that yeah, that's kind of how I see that whole like generalization of tabular models, but I definitely am not an expert on it. Just like
But just from your perspective, because you've been, of course, coming from a different perspective, more on retrieval and re-ranking. So how do how do, for example, customers as Weaviate use XGBoost to do re-ranking?
I guess with recommendation, it's like you have like age, gender, maybe purchase history, these kind of maybe tags. And like I did some kind of like customer churn analysis, and maybe I have a tag on you based on that other what that other model said about you. And so I have all these features that I then use to re-rank like the shirts I'm going to show you for your home feed or your search query. So that's kind of how I see it mostly. But I can definitely, I'm definitely starting to understand this better from listening to you talk about it. Is this idea of like, maybe I have a data set of like, I have like my CRM data set, and I might have come up with some columns to describe my customers with that someone else from the company has different columns that they've been using, right? And now we're going to try to merge these tables, and it's going to be like, does this column agree with this? Is this actually the same column kind of? I guess yeah.
I think what is interesting about the approach of representation learning for tabular ML across different tables is that you can actually learn general patterns. I can imagine that different companies, although their data might be formatted very differently, the same patterns might hold and be relevant in other companies. For example, in health, it doesn't really matter how the data is specified if you can embed this and preserve the generic factors hidden in these, for example, rows that might represent patients or customers. I
Hmm.
think it can transfer such some patterns from one, say, context to another.
Hmm.
And I think that's an interesting thing that XGBoost, I think, will not be able to do. It just doesn't have that high capacity.
Hmm. Yeah, that's really well. I think maybe it would be really nice to kind of like come into so this idea of transferring representations from one table to the other. maybe like to have some examples of visualizing it. Like I imagine maybe I go to archive and I get out like all of the experimental tables, or I know with your GitHub experiment how you got millions of tables from GitHub. Could we maybe have like some examples of like, I guess just like a transferring of table to table more so?
Yeah, I'm thinking of beyond, for example, the data integration problem. Thinking of,
Mm.
well, what we might see, for example, in certain health databases, healthcare databases, you might find specific patterns relating certain ages with certain diseases,
Mm.
and I think such general patterns might transfer from from one city to another city, from one country maybe even to another country. Another, I think, good example in that sense is you have all these like open government data portals, and there are like millions of well, not millions, but like thousands of tables on there. And I think there are just general patterns to extract from these tables. For example, relating GDP with, I don't know, other economic factors, and
Mm.
try to understand the world better
Hmm.
from that. And I think if we could use such, if we could embed that and like retrieve such data, for example, using Weaviate, then we could use, we could augment machine learning use cases in companies, for example, that want to use that economic data for, I don't know, inference on their very specific company goals.
Hmm. Yeah, thank you so much for that. That really helped me understand. I've seen this data set called like wiki tables that was like also like extracting. And yeah, I'm really, I think I'm definitely like my understanding of the whole thing is growing as we've been talking about. All these kind of tables and trying to merge them all together into having this view of the world is so interesting. And yeah, I guess for me, I've always kind of been thinking about like, it's almost like with vector databases and knowledge graphs, graph databases. I think about this a lot is like, what's the best way to kind of represent a fact? Like, can you just have like a natural language sentence that's like a fact, or do you need like a, like a knowledge graph tuple or like a tabular data entry? So how do you kind of think about just like that idea of, the I guess the other approach of instead of kind of merging tables into a big table, I kind of like translate them into facts, and I try to see like if the facts disagree with each other, kind of in natural language for like embedding based retrieval.
Yeah, that's an interesting question. I think so. I've always been very driven by observing what data is around and how data is stored. So one of my observations was that most data is collected and stored, consumed through tables in relational databases, for example, or perhaps less structured in CSV files. So I always took
Hmm.
that perspective and see
Hmm.
that tables typically drive very high value use cases, from churn prediction to healthcare solutions and so on. So I've always been very fond of tables because of that. But yeah, you could also present facts in different ways. But I think the power of tables is that they are so structured, and they provide all these very machine readable interfaces to it. And I think that makes it a suitable format to present data and facts in particular in. Sometimes, tabular formats have been taken a bit more flexibly. So, for example, Wikipedia, now we need to extract tables from Wikipedia and try to restructure it in a very structured format. I think if we would all present it in, very basic tables, I think that would help a lot. And could also, yeah, I think tables are just super rich also because you can complement them with metadata. Um, they come with SQL, for example, as an interface to this data, and you can learn, for example, patterns across that, how other people, for example, query specific tables. You can learn all kinds of signals from that. Um, Of course, similar principles or ideas hold to less structured data, for example, just text. Um, but I've been just coming from, okay, tables are really everywhere in databases, so they take up the majority of the data landscape, the organizational data landscape, and they just serve so many high value use cases across data analysis pipelines. So that's actually why I've been focusing on tables specifically and structured data. But yeah, there are different ways to presenting facts and analyzing that. Yeah.
Yeah, I love that. I mean, yeah, like I guess, like looking at like if you're in the NBA and it's like who's the leading rebounder, I don't know, stuff like stats, you'll see it in like the tables, and I love that. It's a good way of presenting data. I think that really nails it. It makes me question. I'm very curious about like this. Now the language models can see right with like the GPT 4V. What do you think about that kind of like that they can see? So you might want to like visually give them a table. Language models might want to pass visualizations of tables to each other, or is that like a native language? But generally, like I guess this concept of like being able to see data visualization.
Yeah, I think that's a super interesting idea. And I've been discussing this with someone this week, actually, that, when people look at tables, they kind of grasp certain patterns to understand it. And I definitely think that the visual representation of a table, just as an image of it, yeah, I'm super curious to see how this can help also for the for embedding tables and getting insights from them. I haven't seen much of the results. I think just one paper on this where I was like, oh, that's interesting, but it's just in very early stages to see how it's used. I think so far researchers have been evaluating the capabilities and the challenges of using large language models just without the visual
Hmm.
medium, and they've been trying to understand how you should best input a table into, for example, ChatGPT, how sensitive it is, for example, when you ask a certain question and then swap different rows in a table. So tables, by
Hmm.
by default, by their nature, are, well, from a relational perspective, the order of the rows is insignificant, so that doesn't carry meaning. But some of these large language models can be very sensitive to that, just as they can be sensitive to very small semantic changes in, for example, a column name. Just the same semantics, but just a different word, for example, can have actually quite some impact. So I think that opens up new opportunities for research and seeing how we can integrate properties of relational tables into such models. And I think the multimodality will at some point also extend towards tables, but I'm very keen to see where this more like image perspective and the representation of a table from an image, where that will lead to. I'm very curious
Hmm.
to see that.
Yeah, I'm also like I guess another question I have is how the structured in kind of like the vector search world, there's this one idea that you have like an image of a dog and then you have metadata about the image, like maybe the type of dog, the age of it, or color, and then you'd maybe like embed the features as well and maybe average these embeddings. So you have some embedding of like golden retriever, and then you average that with the image embedding for the dog. Do you think that kind of integration of like maybe more unstructured embeddings with the structured components, do you think that can add to the quality of the embedding?
Oh, for sure. I think that's such an interesting comment. Actually, with this latest project called Observatory, we do some analysis that relates to that. So the notion of preserving relations between objects in the embedding space. And I think an analogy into the relational data model is functional dependencies. So given two columns in a table, we might perceive certain relationships between these columns. So, for example, the capital, if you have a column with capitals and a column with country, then you would, well, assuming you would always see the same values for the same countries. So, for example, Amsterdam is the capital of the Netherlands. You wouldn't expect other relations than that. And we've been analyzing table embeddings to see, and particularly column embeddings, to see if these embeddings currently preserve such relationships as well. But so far, we haven't seen that. So, and I think there is also from the knowledge graph embedding space. So you have, for example, TransE, which is an approach for preserving such relationships across entities in knowledge graphs. And I think this would perfectly extend also to the notion of functional dependencies to embed values in tables. And then we can use such embeddings if once they preserve these functional dependencies, so these relationships between columns, then we can also better use that, for example, for data imputation, which then serves perhaps downstream a machine learning model. So I think there's definitely interesting interactions between these two, between these fields. And I
Yeah,
think
well,
it's an interesting suggestion, actually, perhaps more generally, to see how certain concepts of tables, how that can be preserved, or how we can find such relations between certain semantic concepts in the embedding space, even beyond functional dependencies. I think that's an interesting approach, and we should definitely see if we can preserve such relationships semantically.
yeah, I think that's so powerful. I guess like there's this kind of, yeah, like you mentioned TransZ, that kind of like embedding of a particular kind of relationship. Like I guess right now it's like semantic similarity is just like the one size fits all for all. But like instead, if you had some other relationship, and then if you're within this radius, that means that you kind of might also have this relationship, and then we store the structure of that. Yeah, it's also interesting.
Yeah,
Yeah.
I think, and one thing that I was interested about from Weaviate's perspective is, but this is perhaps a little bit off topic, but I was just reminded of this. But from a retrieval perspective, but what kind of embeddings do you currently see? So have you seen at Weaviate? Do you have
Hmm.
customers or I don't know users that actually use or retrieve information and embeddings of tables?
I haven't seen it personally. Oh well, actually, I do. Well, I remember a conversation. Like, I remember earlier there was a bit of like, how do you evangelize vector search with the SQL people, and that was kind of an idea. Is like, I guess back then it was like you would maybe have like an auto encoder, and I mean this was like before the zero shot model. I think now the current prescription would be, could you translate your your table to text, right, to put
Yeah.
it into these embedding models. But I haven't personally seen too much of that. That's why I just find this conversation to be so kind of like eye opening to me. Is I had never thought, before reading your paper on Git tables, and I had never really thought about this idea of searching through multiple tables, or having like a million tables. I think it's quite creative to be thinking like that. And yes, I would say it's quite novel to search, uh, to use like vector search and tabular structured data.
I think, yeah, so one, I think, interesting avenue is now with retrieval augmented generation, that I can assume if you have very accurate embeddings of, I don't know, maybe table rows or columns, or maybe even full tables, just one semantic vector of a table. I can imagine that if you would then, this would help out with RAG as well. From a Weaviate perspective, I
Mm-hmm.
can imagine that so much data is eventually
Mm-hmm.
stored in tables that is relevant to provide as context to LLMs. I can imagine that soon people will start to embed their tables as well. And I'm just super curious to see how how they will retrieve like construct their embeddings, and keen to see that unfold.
Yeah, I think maybe two things I see on that is the first thing is with Weaviate, you define a schema where you define which property you're going to vectorize. So say I'm vectorizing content, but then I also have, I don't know, like metadata about the page. Like say I'm vectorizing the podcast clip, and then I also have like what number podcast it is, who the speaker is, maybe how long the podcast is. And then I can search with the embedding of just the content and then pass in the symbolic data around the object into then the language model. And then one other idea I see from Llama Index is this kind of recursive retrieval. And I think you might find this quite interesting. This is where you would search through Wikipedia pages, like based on their title. And then whichever one is the top match, that one might have a table inside of it. And so like it's like a two-level query where first you're searching through the titles of Wikipedia pages, that took me to billionaires, let's say. And then within billionaires, there is a table that is like, age and exactly how much money they have. Billion, and then you would do the symbolic query within the linked table.
Super cool. Interesting.
Super cool. So maybe wrapping up the podcast, I want to ask you kind of like, this kind of like what's next question, like what kind of future directions are really exciting you?
Yeah, I think on that, first, I'm just so focused on finishing this PhD and starting up new things. One particular direction that I'm interested in is going from insight retrieval from questions to generating questions from tables. So basically, table to question, I would say. Because now most like data teams, let's say, they rely on domain experts to formulate their questions. Fortunately, we can now do that with natural language and then translate that to SQL. So that already makes it much easier for domain experts to access relevant data. But one thing that I'm interested in is see if we can somehow learn what relevance questions are for a given table to ask, so that we can kind of enrich the expertise without needing the query, let's say.
Hmm.
Because you need, yeah, I think there's just I think there is this kind of stat that says that we only use 1% of the data that we have in data warehouses, or maybe it's 5%. I don't know specifically, but we just use really little data. And I think if we would be able to learn access patterns, what kind of questions people ask on certain tables, I think we could then kind of try to move towards more recommendation systems for insights, saying for a given database, like, hey, we see that, I don't know, the number of diseases, for example, in this area has gone up. And then I think that could be really powerful. So that's something that I'm really eager on to move towards.
I love that. I think that's so inspiring, that kind of offline question discovery, and especially with this perspective on tables and not just kind of like the long tail of documents. That's all just so amazing. I also am really inspired by that direction going forward of a more offline kind of processing of your data, and that kind of like self-directed research. It's really amazing. Madelon, thank you so much for, oh, sorry.
Yeah, no, yeah, I'm with you on the excitement, and I'm just also very excited to see startups now ramp up in this space, more research. It's just increasing in embedding tables properly and applications of that. And as we touched on, for example, internal database applications, for example, query plan execution optimization. I think there's also so much space to still explore on the application side. So that's something that I'm very keen on as well. But yeah, it's been really amazing to talk to you about this topic. I'm really excited.
Hey, Madeline, thank you so much for joining the podcast. I've learned so much from this conversation. I'm sure our listeners will as well. And congratulations so much on the PhD. It's super well deserved. There's so many amazing publications, and this whole table representation learning is just super interesting.
Thanks so much, Connor. Thanks for having me. It was really awesome.